This lesson is about properties of parallel lines. The goal is I can use properties of parallel lines to find angle measures. Okay, our first vocabulary word is parallel lines. And parallel lines are coplanar lines that do not intersect. So here's a picture to the right of two parallel lines. Let's say that lines J and K are parallel. Now the way that you're going to write this is you could say line J. The way that we denote two lines are parallels, we use two lines that are straight up and down. So line J is parallel to line K. Now the way that we show that on our diagram is by drawing arrows. So you're going to draw a small little arrow on line J and another small arrow on line K. That means that those two lines are parallel. So by looking at a diagram, you can always tell whether lines are parallel if they have those arrows on them. Now let's say there was a diagram with two lines that are parallel, so two sets of lines are parallel. You could have one arrow on the one set of parallel lines, and then you could add a double arrow, which would look like this, to show another set of parallel lines. Let's look at our first postulate, which is the corresponding angles postulate. This says if there's two parallel lines cut by a transversal, then each pair of corresponding angles is congruent. Looking at the diagram, we can tell that the two lines are parallel because of the arrows on them. Then we're going to find the corresponding angles and write that they are congruent. So for example, angle 1 is corresponding with angle 5. So we would say angle 1 is congruent to angle 5. Another pair of corresponding angles, angle 2 and angle 6. So angle 2 is congruent to angle 6. Another pair of corresponding angles is angle 3 and angle 7. So we can say angle 3 is congruent to angle 7. And then we have angle 4 and angle 8 are corresponding angles. So angle 4 is congruent to angle 8. So this is only true if the lines are parallel. Alternate interior angles theorem. This theorem states that if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. So let's take a look at our diagram. We have those two parallel lines with the arrows on them, so we know that they're parallel. Now let's find our alternate interior angles. Angle 3 is an alternate interior angle with 6. So that means that angle 3 is congruent to angle 6. And then there's one more pair of alternate interior angles, and that's angle 4 and angle 5. So angle 4 is congruent to angle 5. Next is same side interior angles theorem. And this states that if two parallel lines are cut by a transversal, then each pair of same interior angles is supplementary this time. So this one is different from the other ones. So remember, supplementary means that those two angles add up to be 180 degrees. So if we look at our diagram, again, we have two parallel lines. We have to have parallel lines in order for this to work. We have angle 3 and angle 5. Those are same side interior angles. So angle 3 and angle 5 are supplementary, so they add up to 180. And then we have another pair, and that's 4 and 6. Those are same side interior angles. So angle 4 and angle 6 are also supplementary. And the last theorem is alternate exterior angles theorem. And this states that if two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. So if we look at our picture to the right, we have two parallel lines cut by a transversal, and angle 1 is an alternate exterior angle with 8. So that means that angle 1 is congruent to angle 8. And we have one more pair, and that is angle 2 and angle 7. So angle 2 is congruent to angle 7. Now if we look back at these four postulates or theorems, you'll notice that the corresponding angles the pairs are congruent. For alternate interior angles, the angles are congruent. And with alternate exterior angles, the angles are congruent. The only one that is supplementary is same side interior angles. The way that I like to remember this is same side starts with S's and so does supplementary. So you can think same side supplementary. The other three are going to be congruent. And I want to remind you that this only works when there's parallel lines. Let's take a look at example 1. The directions say, identify all the numbered angles that are congruent to the given angle. So it's telling us that they want us to find a vertical angle, a corresponding angle, and an alternate interior angle given 55 degrees right here. So if we're given 55 degrees, which angle is vertical? And that's the angle across from 55, which is angle 2. So I know that vertical angles are congruent. So the measure of angle 2 is equal to 55 degrees. Next, let's find a corresponding angle with the 55 degrees. Well, the corresponding angle with 55 degrees is angle 7. And I know that corresponding angles are congruent, so the measure of angle 7 is also equal to 55 degrees. Last, which angle is an alternate interior angle with 55? And that would be angle 6. It's on opposite sides of the transversal and they're both on the interior. Alternate interior angles are also congruent, so the measure of angle 6 is also equal to 55 degrees. Let's look at number 2. So first is vertical. What is vertical with 132 degrees? And that would be angle 3 is vertical with 132 degrees. So the measure of angle 3 is equal to 132 degrees. Next is corresponding. What is corresponding with 132 degrees? And that would be angle 5. So the measure of angle 5 is also going to be 132 degrees because corresponding angles are congruent. The last one is alternate exterior angles. Angle 7 is an alternate exterior angle with 132 degrees. So we can say the measure of angle 7 is equal to 132 degrees because alternate exterior angles are congruent. Number 3, the directions say, find the measure of angle 1. If I look at the angle that's given, we have 120 degrees and we have angle 1 right here. These are considered same side interior angles. And we know that same side interior angles are supplementary. So that means that those two angles are going to add up to be 180 degrees. So we can do the measure of angle 1 is equal to, since both of them together are 180 degrees, I can do 180 minus 120, and 180 minus 120 is 60 degrees. So the measure of angle 1 is 60 degrees. Number 4, we have 65 degrees in angle 1, and again these are same side interior angles, so therefore they're supplementary and add up to 180. Another way that you could solve this is by setting up an equation. Let's say that I'm going to make angle 1, I'm going to put an x there, and I'm going to set up an equation. I'm going to add x plus 65 is equal to 180. Then I'm going to solve for x by subtracting 65 on both sides. And we get x is equal to 115. So therefore that means the measure of angle 1 is equal to 115 degrees. So those are two different ways that you can solve that problem. You can pick whichever way feels more comfortable for you.